my name is Kiley Arnold, and I'm an undergraduate student in the BS Exercise Science program, an immersive scholar, and a student research assistant in the Health Assessment Laboratory. This presentation focuses on identifying a relationship between heart rate variability and capillary refill in the seated and supine positions. Heart rate variability is a non-invasive measure of the autonomic nervous system function, including parasympathetic and sympathetic branches as seen in the diagram on the right. The autonomic nervous system controls many involuntary bodily processes like heart rate. R-to-R interval differences found on an electrocardiogram are used to calculate the time domain metric of the natural log of root mean square of successive differences, or lnRMSSD. Capillary refill is a clinical assessment of blood flow reaching the capillary beds. It is commonly measured by applying manual pressure to the finger and observing the speed at which color returns. The parasympathetic and sympathetic systems influence capillary refill via vasoconstriction by releasing hormones to adjust to stimuli, as seen in the figure on the right. ANS function is related to vagal tone through the vagus nerve regulating heart rate variability. However, these concepts fail to highlight the relationship between heart rate variability measures and capillary refill. Therefore, the purpose of this study is to determine the relationship between the lnRMSSD heart rate variability data and capillary refill in the seated and supine positions. This study included 18 participants, 9 females and 9 males. Each participant wore a validated core sense finger sensor, as seen in the top right image, on the left and rightmost distal fingers for 5 minutes in the seated and supine positions. The finger sensor can remove artifacts that may indicate an ECG abnormality when they are not due to the electrical activity of the heart, such as movement or shaking. Capillary refill data was collected through applying manual pressure to the participants' left and rightmost distal fingers. The duration for color to return after finger blanching was recorded in seconds. Results for both the HRV data collection as well as capillary refill were averaged between left and right sides for seated and supine positions. Using the calculated averages, bivariate correlations were run to examine relationships between lnRMSSD data and capillary refill time. A Shapiro-Wilks test for normality was used, and due to the skewed distribution, a Spearman's correlation analysis was performed. IBM SPSS software was utilized to conduct all statistical analyses. An alpha of 0.05 was used to determine statistical significance. Interpretations of the correlations can be seen in the graph to the right. Small and non-significant correlations between capillary refill and lnRMSSD data were found in both positions. The clinical significance of this study is that resting measures of HRV data were not significantly associated with capillary refill, which suggests that heart rate variability is not indicative of arterial tone in healthy college-age students. Future research should determine if other HRV measures are more closely associated with capillary refill. It should also examine if those with vascular pathologies provide a different outcome, as well as use a larger, more diverse sample size, as this study was primarily white, college-age individuals. I would like to thank my faculty mentor, Dr. David Cornell, as well as my fellow research collaborators for assisting me in this project.